Hello students, in this video tutorial, I will guide you on how to solve problems related to making inferences for correlation coefficient and slope for a population. Suppose you are given with this problem. One of the student assignments is to determine how much copper sulfate will dissolve in water at different temperatures. The results are shown below. So here are all the 7 pairs of data of x and y. There are altogether 6 sub-questions. The first one is to find the equation for the data above. Second is to compute the standard error of estimate or SE. The third one is to compute a 95% confidence interval for y that will dissolve at lower temperature when x is equal to 15 degrees Celsius. D. Determine the statistical significance of the sample correlation coefficient R using alpha equal to 0.05. E. To compute at 95% confidence interval for beta and interpret the results. And the final question is to test the null hypothesis that the slope of the regression line is 0 using a 5% level of significance. So let's have a look at how we're going to solve all of these problems in the following slides. The first question asks us to find the equation for the data above. So in order to solve for the equation, we have to apply what we have studied before, that is the least square equation. And this is the general form of least square equation, where we have to solve for the a and b values. The formula of a and b is given here. And in order for us to solve these a and b values, we have to first find the values of the related terms in the formula. For example, the summation of xy, summation of x, summation of y, and summation of x squared, as well as the average of x and the average of y. In order to solve all of these problems, we have to extend the table given to us by finding the additional information that are related to all of those terms. So in the following slide, I will show you how to extend the table by adding all of the necessary information. This is the extended table that I mentioned just now. Actually, I have mentioned or discussed about how to create this extended table in the previous lecture or tutorial on how to solve for the least square equation. So if you see here, the first 2 columns represent the original data given in the question, whereas the last 3 columns represents the additional information that we need to solve in order to solve for the b and a values. So the last 3 columns are xy, x squared, and y squared. And also we have to find what is the summation of x, which is given here as 280, summation of y 213, summation of xy 9940, summation of x squared 14,000, and summation of y squared 7229. And also we have to find what is the average of x, which is given as 280 divided by 7, so that gives the value of 40, and the average value of y is given as 213 divided by 7, and the value is 30.429. Substituting these values into the formula of a and b, we will get the value of b as 0.5071 and the value of a as 10.144. So only then we can substitute into the general form of the least square equation, where we get the equation of y equal to 10.144 plus 0.5071x. So that answers the first equation in this problem. The second question asks us to compute the standard error of estimate or SE. This is the formula of SE. In order for you to use this formula, you just have to consider the second line of the expression here, whereby you have to find what's the value of the summation of y squared, summation of y, summation of xy, as well as the values of a, b, and n. These values can be obtained from the extended table that we have created before. So by substituting the related values of all the terms needed in the formula, you will get the value of SE equal to 2.433. So that answers the second question of this problem. In the third question, we have to compute a 95% confidence interval for Y that will dissolve at lower temperature when X is equal to 15 degrees Celsius. This is the general form of confidence interval for Y, where we have to solve for the Y value when X is equal to 15 degrees Celsius, and also the value of E. This is the formula of E. First, we have to find what's the value of Tc or critical T, and also the value of Se. But we have solved the value of Se in the previous question, where we get the Se equal to 2.433. Tc represents the critical T, which is obtained from the student's T distribution table by using the confidence level based on the degree of freedom given as n-2. And since in this problem, the n is equal to 7, so the degree of freedom is given as 5. In the later slide, I will show how to find the critical T from the student T distribution table. This is the student's T distribution table. What we have to find out from this table is the value of Tc. So the information given to us is df is equal to 5, and it is stated in the equation that the confidence interval is 95%. So the tell area is given as the difference between 100% and 95, that is equal to 5%, or if we convert to decimal points is 0.05. But that value represents both tells. So we have to divide the value into 2, giving the final value of upper tell area as 0.025. So what we have to find out from the table is the value of Tc when df is equal to 5 and when the upper tell area is equal to 0.025. So that gives the value of 2.571. So since we have the value of Tc and Se, which is obtained from question B, then now we can solve the value of E using this formula. And we have to find out the X value, which is given in the question as 15 degrees, and we substitute into the E formula here. So eventually, we will have the value of E equal to 7.311. We are not done yet with the third question. So now we have solved the value of E, which is equal to 7.311. So the next thing that we have to do is to solve the confidence interval for Y, which is given by this general form. But first, we have to solve the value of Y when X is equal to 15, because that is stated in the equation. So what we have to do is we just have to substitute the value of X equal to 15 into the least square equation that we obtained in question A. So the Y value is given as 17.75. So knowing the values of Y equal to 17.75 and the E equal to 7.311, we substitute into the confidence interval for Y. So at the end, we will get the confidence interval for Y that is between 10.439 and 25.061. So that answers the third question of this problem. In the fourth question, we have to determine the statistical significance of the sample correlation coefficient R using alpha equal to 0.05. Here, we have to apply the 6 steps for making an inference for correlation coefficient. The first step is to establish the hypothesis, both null and alternative hypothesis. The null hypothesis states that the rho is equal to 0, whilst the alternative hypothesis states that the rho is not equal to 0. In the second step, we have to define the alpha value, but since it is stated in the equation, we just have to use the value given, which is equal to 0.05. In the third step, we have to compute the R value, and once we have computed the R value, we have to convert it to T value. This is the formula of R, which is the one that we have learned in the previous tutorial. And you just have to substitute the value of the summation of xy, summation of x, summation of y, summation of x squared, and summation of y squared based on those values that you have in the extended table in the first equation. And once you get the r value, then you have to use the formula of t here in order to get the t value. In this problem, the r value is solved as 0.9814 and the t value is 11.4236. In the fourth step, we have to find the p value based on the information that we have, that is t equal to 11.4236 and the degree of freedom equal to 5. We are not done yet with step 4. What we have to look for in this step is the value of p, which is actually the value of the upper tail area in the t distribution table. So based on the information that we have, we know that the df is equal to 5 and the t is equal to 11.4236. What we have to find out is the p value when t is equal to 11.4236. But apparently in this case, we couldn't find the value of t equal to 11.4236 because it exceeds the maximum limit here. But what you can predict is that you can see that the trend of t is increasing from left to the right. So the highest value here, when t is equal to 6 point something, the p-value is given as 0.0005. So you can expect actually the p-value when t is equal to 11.4236 will be less than 0.0005. So what you have to do next is that you want to compare the p-value with the alpha value, and the alpha is equal to 0.05. Since we know that the p-value for t equal to 11.4236 is way smaller than 0.0005, which is apparently smaller than 0.05. That is the alpha value. So the decision that we have to make in this problem is to reject the null hypothesis and to accept the alternative hypothesis. In the final step, we have to make a conclusion. So the conclusion that we have to make is that at 5% level of significance, there is a correlation between temperature and copper sulfate. So that answers the fourth question of this problem. In the fifth question, we have to compute the 95% confidence interval for beta. This is the general form of the confidence interval for beta, where we have to substitute the value of b and E slope. Recall in the first question, we have solved the value of b, which is equal to 0.5071. E slope is given by this formula. We have to substitute the value of Tc and Se. We got the value of Se equal to 2.433 from question B, and Tc equal to 2.571. So solving the terms in the E slope formula, we got the value of 0.1182. Substituting the value of B into the general form of the confidence interval for beta, eventually we will get the confidence interval for beta between 0.3889 and 0.6253. So that answers the fifth question of this problem. The sixth question asks us to test the null hypothesis that the slope of the regression line is 0 using a 5% level of significance. In this problem, we have to apply the 6 steps for making an inference for slope. The first step is to establish the hypothesis. The null hypothesis is given as beta equal to 0, and the alternative hypothesis is given as beta is not equal to 0. In the second step, we have to define the alpha value, which is given in the equation as 0.05. In the third step, we have to compute the b value, and we have to convert it to t value. The v value is given by this formula, and also the t formula is given as follows. And in the previous question, we have solved the b value, and the b value that we got is 0.5071. Substituting this b value into the t formula here, we will get the value of t equal to 11.027. In the fourth step, we have to find the p-value based on the information that we have, that is t equal to 11.027 and the degree of freedom equal to 5. We are still in step 4. What we have to look for in this step is the p-value is actually the same as what we looked for in the previous question when we make an inference for the correlation coefficient, where we have to find for the p-value, which is the upper tail area, based on the information of t and the degree of freedom. In this case, the t is 11.027 and the df is 5, but apparently we can see that the same case happened where the t value here exceeds the maximum limit. What we can predict is that the p-value when the t is equal to 11.027 is way smaller than 0.0005. So since we compare the p-value with the alpha value, which is 0.05, and in this case, it is way smaller than 0.0005, and of course, it is much smaller than the alpha value, which is 0.05. So the decision that we have to make is to reject the null hypothesis and to accept the alternative hypothesis. In the final step, we have to make a conclusion, and since the alternative hypothesis that we accept states that the beta value is not equal to 0, the conclusion that we can make is that at 5% level of significance, there is a relationship between the temperature and copper sulfate. So that answers the sixth question of this problem. We have come to the end of today's tutorial. Let's recap what we have learned today. First, we learned how to make an inference for correlation coefficient. Second, we determine the confidence interval for y. Third, we make an inference for slope. And finally, we determine the confidence interval for beta. That's all for today. Thank you very much for watching. For more video tutorials on statistics, please subscribe No Statistics No Talk on YouTube. Have a nice day.